Good morning, student. Here we shall discuss what is optical instrument. You are familiar with optical instrument. Which are optical instrument? Yes, simple microscope, compound microscope and a telescope. What is the necessity of this optical instrument? Let us see in this topic. Okay, when we look any object, then its apparent size depends on the distance of the object from our eye. To see the distance object clearly, it should be brought close to our eyes. And if we brought close to our eyes get strained. We can't see the clear image of that object. The image may be the blurred image. Therefore, there exists a least distance of the object from eye at which the object can be seen clearly without straining our eyes. This distance is called as DDV. Then what is the DDV? Distance of distinct vision. For first D is for distance, second D for distinct and V for vision. V for vision. Okay, and for normal human eye, this distance is 25 centimeter. For normal human eye, this distance is 25 centimeter. The image formed on the retina of our eye depends on the angle made by the object with our eyes. And that angle is called as visual angle. This angle is very important. That angle is called as a visual angle. When we bring any object closer to our eyes, then what happens? Clarity increases. Okay, and this visual angle increases. This visual angle increases and therefore clarity increases, but there is a limit to this distance. Okay, when the distance is less than DDV, means for 25 centimeter, ओके 25 सेंटीमीटर अंतर तुम्हाला कळते साधारणतः इतकं. ओके, परंतु त्याच्यापेक्षा जर आपण कमी इथं जर आपण धरले एखादी ऑब्जेक्ट आणि आपण पाहण्याचा प्रयत्न केला तर आवर आईज गेट स्ट्रेन. Means when the distance is less than DDV, our eyes get strained, and in that case we have to use a convex lens of small focal length, and that convex lens of small focal length is called as simple microscope. Already you are familiar with this simple microscope. This simple microscope is used by the jewelers, watchmakers, okay, and electric technician also. ओके, यांच्याकडे हा कायम कॉन्व्हेक्स लेन्स म्हणजे सिंपल मायक्रोस्कोप हा कायम असतो की त्यांना ते स्मॉल पार्ट्स हे पाहायचे असतात की जेणेकरून की त्यांना ते काय दिसतात ते मग सिंपल मायक्रोस्कोपमधनं पाहिल्यानंतर त्यांना ते लार्ज दिसतात ते. ओके, आणि देअरफॉर धिस सिंपल मायक्रोस्कोप इज यूज बाय द वॉचमेकर्स, ज्वेलर्स अँड इलेक्ट्रिक टेक्निशियन्स. Okay, therefore, what is the necessity of optical instrument? In optical instrument, visual angle is increases. Therefore, role of visual angle is important in the case of optical instrument. कारण एखादी जर वस्तू जर आपल्याला नेकेड आईजने व्यवस्थित दिसत नसेल तर you can use the optical instrument, and that object may be the small object, of course. Okay, here we shall discuss this point in detail. Okay, and we have to obtain the magnifying power of a simple microscope. On this blackboard there are the two ray diagram. First ray diagram is for visual angle alpha made by the object with our eyes. First ray diagram is for visual angle alpha made by the object. Object is here AB with eye. And second ray diagram is for visual angle beta made by the image A dash B dash with the eye. Okay, here consider that therefore convex lens is kept here and object is kept here. What is the AB? AB is the object which is kept within the focus of the lens. Then this convex lens produces its virtual, magnified and erect image A dash B dash, name should be this A dash B dash on the same side of the ऑब्जेक्ट. म्हणजे ज्या साईडला आपण ऑब्जेक्ट ठेवलेली आहे त्याच साईडला त्याची काय मिळणार आहे तुम्हाला इमेज मिळणार आहे. देन व्हॉट इज द मॅग्निफाईंग पॉवर or it is also called as a angular magnification. Magnifying power is magnifying power ला MP म्हटलं तरी चालेल. ओके, therefore MP is equal to the magnifying power which is defined as it is the ratio of, okay, what is this? It is the ratio of visual angle made by image upon visual angle made by object at DDV, when the object is at a DDV. When we can change this object distance, then we can also obtain the magnified images from the distance DDV to the infinity. Okay, हे जर तुम्ही ऑब्जेक्ट डिस्टन्स चेंज केलं तरी तुम्हाला काय मिळणार आहे, इमेज डिस्टन्स हे सुद्धा काय झालेलं दिसणार आहे, चेंज झालेलं दिसणार आहे. ओके, देअरफॉर MP इज इक्वल टू द व्हिज्युअल अँगल मेड बाय द इमेज अपॉन व्हिज्युअल अँगल मेड बाय द ऑब्जेक्ट ॲट DDV. देअरफॉर MP इज इक्वल टू द, ओके, व्हिज्युअल अँगल मेड बाय द इमेज इज बीटा, दॅट अँगल इज बीटा, अपॉन visual angle made by the object is alpha. Okay, from the figure what is the value of tan beta? Tan beta is nearly equal to the beta and which is equal to the S. What is this? BA upon AP. Okay, what is tan alpha? From figure A, tan alpha is nearly equal to the alpha which is equal to the S BA upon D. Okay, put this substitution in equation number 1. What do we get? MP is equal to the, what is the beta? BA upon AP. AP is U. Okay, AP is U into alpha is AB or BA upon D which is equal to the BA upon U into D upon BA. Okay, therefore this BA get cancelled, D upon U, and therefore we get MP is equal to the D upon U, and this is the equation for magnifying power of simple microscope. D for the distance, DDV for normal human eye it is the 25 centimeter and U is nothing but a object distance. Okay, then we have to see the two cases. Okay, let us see that. first case. Here we write this again, MP is equal to the D upon U. We get this equation, D upon U. Okay. Then, if the image is formed at DDV, in that case, what is the value of V? V is equal to the D. Then in that case, F is equal to F. Okay. Then V is equal to here minus D घ्यावं लागेल. कारण this distance is minus U, again this distance is minus D. Okay. Then U is equal to the minus U. Then what is the length equation? 1 upon F is equal to the 1 upon V minus 1 upon U. Then 1 upon F is plus F आहेच ती value. Therefore, it is plus F. 1 upon V, V is minus D. Okay. Minus 1 upon minus U. Therefore, 1 upon F is equal to the, this is minus minus plus, therefore 1 upon U minus 1 upon D. Okay. And multiply this equation by the capital D. Therefore, D upon F is equal to the D upon U minus D upon D. Okay. Then what do we get here? See this, D upon F is equal to the D upon U. What is the D upon U? D upon U is MP, magnifying power of a simple microscope, minus 1. D upon D is 1. Then what is then MP? In that case, MP is equal to the D upon F plus 1 or 1 plus D upon F. Okay. म्हणजे first case मध्ये when the image is formed at a DDV, कारण जर distance आपण object change केलं तर image can be formed in between the DDV to the infinity. Therefore, if the image is formed at a DDV, therefore V is equal to minus D, and you get this MP equation is equal to the D upon F plus 1. Okay. Here I write this equation, MP is equal to the 1 plus D upon F. Okay. This is the second equation. Now second case, if the image is formed at a infinity, then what is the V? V is here infinity. Then F is equal to the F, U is equal to the minus U. Okay. Then our length equation becomes 1 upon F is equal to 1 upon V minus 1 upon U. Then 1 upon F as it is, because F is F is equal to 1 upon infinity, V ची value put up केली, minus 1 upon minus U. Therefore, 1 upon F is equal to, this becomes 1 upon infinity is 0, this minus minus plus, therefore 1 upon U. Multiply this equation by the capital D, therefore D upon F is equal to the D upon U. What is then D upon U? It is MP. Therefore, we get here MP is equal to the D upon F. This is the minimum value of magnifying power when the image is formed at a infinity. And when the image is formed at a DDV, then we get the maximum magnifying power of simple microscope. Okay. Therefore, it is the maximum value of magnifying power of simple microscope, and it is the minimum value of magnifying power of simple microscope. Okay. Then we see the next optical instrument, compound microscope. Magnifying power of compound microscope. Let us see this. Just we have seen the magnifying power of a simple microscope. Then there are the two cases. Okay, we get in first case when the image is formed at a DDV, then we get MP is equal to the 1 plus d upon f, and in second case we get MP is equal to the d upon f. Means MP, magnifying power of simple microscope, depends upon the focal length, and it is inversely proportional to the focal length. Means if you have to increase the magnifying power, focal length should be decreased. But there is some limit to which the focal length can be decreased. Okay, किती आपण decrease करू शकतो focal length? कारण with small focal length, the lens becomes thicker and various defect of lens occur. Therefore, we can't increase the focal length beyond certain limit, and therefore we can't increase the magnifying power of simple microscope beyond certain limit. Okay, and therefore in that situation we have to use the compound microscope. Then what is the compound microscope? Compound microscope consists of two convex lenses. First is called as a objective, second is called as a eyepiece. The lens near the object is called as a objective. The lens near the eye, here is our eye, okay, is called as a eyepiece lens. This objective lens has a small focal length and small aperture. This eyepiece lens has a large focal length and large aperture. Okay, and these two lenses are fitted in a tube, and the distance between that lens can be adjusted. Okay, and that whole apparatus, that whole optical instrument is called as a compound microscope, which consists of the two convex lens. Okay, one is called as a objective and other is called as a eyepiece. Then see this ray diagram. Okay, in this ray diagram, the tiny object AB is placed in between the f and twice f of the objective. Here is our small object. Then this objective lens produces its real inverted and magnified image. Okay, then for this eyepiece, this image A dash B dash acts as a object. Then it produces its image A double dash B double dash, and this image is virtual and magnified. Okay, this image A dash B dash is real, inverted and magnified, but A dash B dash, that image is virtual and magnified. Then what is the magnifying power of compound microscope? Magnifying power of compound microscope is defined as it is equal to the beta upon alpha. Beta means visual angle made by the image with eye, and alpha means visual angle made by the object with eye. Then from figure, what is the tan beta? Tan beta is nearly equal to the beta, which is equal to the A double dash B double dash, okay, upon VE. Okay, the distance is nothing but a VE, and which is also equal to the A dash B dash upon UE. Okay, B is equal to the tan beta is equal to the beta is equal to the A dash B dash upon UE according to the trigonometry. Similarly, tan alpha is equal to the, what is the value of tan alpha? It is AB upon D. We have seen in previous case. Okay, therefore, and which is nearly equal to the alpha. Therefore, MP is equal to the beta A dash B dash upon UE into D upon AB. Okay, beta ची value ही put up केली. Alpha is AB upon D, therefore it becomes D upon AB. Rearrange this equation, therefore MP is equal to the A dash B dash upon AB into D upon UE. Okay, and just in previous case, what is the D upon UE? D upon UE is ME, magnifying power of eyepiece. ME. What is this? A dash B dash upon AB. This is the linear magnification and it is denoted by MO. Therefore, we get here MP is equal to the MO into ME. MP means magnifying power of compound microscope or angular magnification of compound microscope, which is equal to the MO. MO for linear magnification. This factor denotes A dash B dash upon AB is the linear magnification. This is the MO and D upon UE is the ME, means magnifying power of eyepiece. Okay, this is the magnifying power, this is the linear magnification and this is the magnifying power of compound microscope. Okay, this is all about the optical instrument and its magnifying power. Let us stop here. Okay, all students subscribe the channel.